All right, good. So I just started the recording. We're coming back from lunch. I forgot, for those of you watching on YouTube, to record this first part. So look for a little bonus, very short video later on that, but I'll leave it on the screen for a second if you want to pause and look at it. All we did was go over the basics of the sine graph and the cosine graph. And actually what we're about to do, I think, is more helpful because it's kind of like a shortcut of these graphs. So go to the very bottom of your page and see how it says sine, negative sine, cosine, and negative cosine. We're going to do kind of like a little. Hi, Gabe. He always comes and like interrupts my class. I'm shocked that he didn't do that today. So, all right, whatever. So we're gonna do little quick graphs of those. Kind of remember what those shapes look like, and then we're gonna do some transformations. Class we introduced the idea of horizontal and vertical shifts, but we didn't do any of those. So we'll see what we can kind of get to. So let's go down to the bottom. So we're going to redraw our sine graph. Again, we literally just did this, but now we're putting it in a much shorter type version. So remember, sine, it goes all the way to 2 pi. It goes up as high as 1. It goes down as low as -1. And sine specifically goes through 0 at 0 and at pi and at 2 pi. At pi over 2, it's up at 1. And 3 pi over 2, it's down at -1. Again, earlier we just went over why all that is. We're just doing a nice little sketch to get the motion in our hand. Next one I'm going to do is the negative sine graph. I don't know if I looked at that with you guys. Brooke, you don't have this. I gave this to everybody at the beginning of class. I saw you look confused. I was like, oh, we've got to tell her she doesn't have this. Okay. Negative sine, did I do with you guys? No, maybe. I think I wanted to do negative, but we didn't get to it. Negative is just the flip. So all my zeros are the same, but instead of starting at 0 and going up like this, it's going to start at 0 and it's going to go down like that. So I still am at 0, and at 2 pi, and at pi. But instead of being up at +1 at pi over 2, it's going to be down at -1 there. So I'm going to go down here. Oop, that's that point. It should be dashes, not points. That's better. So down at -1 and then through 0 and then up at +1 and back. So if you look at positive and negative sign, they're just they flipped over the x-axis. That's all that happened. We're going to do cosine as well. Cosine, for some reason, is really funny in my brain because it doesn't look like a nice curve like sine does. Sine looks like a wave. Cosine doesn't. It looks kind of like a horseshoe to me. And so I struggle with that one. So if you struggle as well, we really just need to know these 5 points and we can figure out the rest as we go. So cosine does not start at 0, 0. It starts at 0, 1. So at the point x is 0, then y is 1. And also at 2 pi. When x is 2 pi, then y is 1. At pi, you're either at the lowest point in our case or the highest point in the other case. And then it hits the zeros in cosine at my over 2s, my pi over 2 and my 3 pi over 2. So at these points, that's when I hit my zeros. Still at 1, still a -1. And this graph is kind of funny, so just try and make it look as curved as possible. Not a great job, but it's as good as it's going to be. Negative cosine is different because instead of starting at +1, I'm starting down at -1 and going through the exact same points, but it's just flipped like that. So I'll do that on the other picture. I really like putting them on top of each other because I think that it's cool to see the waves as they go. But I also know that that can be confusing. So again, I just did positive cosine here. Let me go to negative cosine and then I'll zoom out for anyone who needs to see all of it. This time it doesn't start at +1, it starts at -1, which means that it ends at 2 pi, also at -1. Instead of pi being my lowest point, it's now my highest point, and still at my pi's over 2, normal pi over 2 and 3 pi over 2, I'm at 0. So it's just like a upside down horseshoe. It kind of looks like a bell-shaped curve in stats. So if any of you ever take stats, kind of looks like a bell-shaped curve. All right, and I'll zoom out now so you can see all of it. So again, all we did was we just did the small graphs, just a little sketch of sine, cosine, negative cosine. What we're going to do now is do our transformations. So now we've just graphed normal sine and cosine. Now we're going to graph changes to them. And we're going to start by changing the amplitude, the vertical distance, and the period, the horizontal distance. So the first one we'll do, let's do my amplitude change. Let's just do y equals 2 sine theta. That theta can be x. It can be any variable I want it to be. I'm going to try to keep it x or theta, but sometimes I mess up. The only thing that's here that's different is that I've got a 2 out front. That 2 out front affects my amplitude. So instead of my amplitude just being 1, my amplitude is now 2. I'm not going to change my period or my horizontal distance, so it's still 2 pi, and my starting point is still 0, 0. I know that because it's sine. You got to look at your trig function. We're just dealing with sine and cosine today, but in 4-5, we get to tangent and cotangent and cosecant and secant, and it's a mess. My zeros are still the same. They're still at 0, they're still at pi, they're still at 2 pi. The zeros don't change. Oh, why did you guys let me write amplitude was 1? Amplitude is 2. I'm so sorry. Yeah, what I was about to say is the only difference now is my amplitude is not 1, it's 2, which means I'm stretching now to positive 2 and negative 2 instead of positive 1, negative 1. Becca? So this one, its height would be 4 because I'm going to go all the way up to positive 2 and I'm going to go as low as negative 2. The number in front is already in the amplitude form, and that doesn't tell me my height. That tells me what I'm multiplying all my sines by. So if I was multiplying sine that was 1 by 2, then it's going to go up to positive 2. And if I was multiplying by negative 1, it'd go down to negative 2. Does that make sense? Okay. So my height is still 4, but my amplitude is 2. So now it's just stretched a little bit higher than it was before. You only have to give me this side. If you want to give me the other side, go for it. I love graphing both sides, but I know most of us only getting one is good enough. So that is fine with me. That's it. That's an amplitude change. That's all I care about. Okay. Next is a period change, which I think is the harder one. Let's do this. Let's do y equals sine 2 theta. Do you see how that 2 is not in front? It's next to the theta. It's not in front of the sine. Whenever you have something being affected to the x or the theta, that's doing horizontal stuff. It's changing my x. Anything that's out front changes my y. It changes my vertical shifts or changes or whatever. Now, this is not like amplitude where I can just be like, oh, my period's just 2. No, I have to do a little bit of math. My amplitude is still 1 because there's nothing in front of my sine, but I call this point I call this B, and I'll go down to the bottom and show you what that looks like in a second. But you find the period by doing 2 pi divided by whatever number this is. So I'll say in the future 2 pi divided by B. In this case, 2 is my B. So 2 pi divided by 2. The 2's cancel, and so I just have pi. What that means is instead of having 2 pi as a distance to do my entire wave, I now have to do an entire wave in pi. And half of that I have to squeeze it in, shift it in so that I can do a whole sine wave in pi units instead of stretching out for 2 pi units. Okay? So let's look at that. Instead of ending at 2 pi, starting at 0 and ending at 2 pi, I'm ending at pi. That's the last point. So we need our 5 important points. We need 3 of the zeros and the 2, 1 high and 1 low. My new middle point is now at that pi over 2. And my new high point is in between 0 and pi over 2. And my new low point is between 2 pi over 2 and pi. Instead of being able to take up all the way to 2 pi, I had to like shove it in. Yeah. It can, one whole cycle ends at pi. Yes. It keeps going and going, and I will draw that for you. But this is what sine of 2 theta looks like. Do you see how that's different than the last one? The last one was stretched really tall. And it's even different than, bless you, the very first one. It's different than the very first one because it's a little bit tighter in. I tried to use the exact same chart so you could see the difference. Gabby, question? That's exactly what we just showed. The difference is the 2 in front is a vertical shift, is a vertical stretch. It makes it longer or thinner. And the 2 on the inside squishes it horizontally. And again, I can keep doing this forever if I want to. Like that. Okay. Now we're going to do these together. Are you guys ready for that? Ready to do them together? You're like, not really, but I guess that's what we're about to do, isn't it? And I'm pulling questions from in here, so we probably won't go back and necessarily do all of these problems, but I'm trying to pull some from in here on your normal notes. So the next one we're going to do is just combine those two things. We're going to do y equals 2 sine 2 theta. So I'm on the back side at the very top. I'm combining these two. I already told you it's going to change both our amplitude and our period. So by changing it, the amplitude is now 2. Just like the first example we did. And the period is now 2 pi divided by 2, which is just pi. Now that we're doing a couple different transformations, I think it's a little helpful to make myself a box, okay? I like boundaries. I like to know how far I need to go, how far I can go. So I know that I can go as high as 2, as low as -2, and as far over as pi. You do not have to do this. And I just do little dash marks so that I know that it's not really part of the graph. It's just kind of a barrier for me. It's a nice little like wall I'm making. My whole sign needs to fit in that box. It needs to go as tall as that box. It needs to go as low as the box. It needs to go from the left all the way to the right of that box. I found that box by looking at the 2 for my amplitude and the 2 for my period. Anyone have any questions yet? Yeah. Yep. We've done the same number twice now. The next one will be different, and you'll see how that changes it. So you take whatever the number in front of theta or in front of x is, and you divide that by from 2 pi. Divide it from 2 pi. So I'm going to do this. I'm going to take my pen. I know that sine always starts at 0, and it ends at 0, and its middle point is 0. It's not a negative sign. It's a normal sign. So it's going to go as far up as I can go to the highest point, and it's going to go as far down as I can go. Any questions on how I separated that? I'm essentially doing halves and halves and halves. So like I knew I started and ended at 0, and then halfway in the middle is 0 again. And then halfway between these two is another point, and then halfway between those two. So I'm going to use that kind of logic as we go along. Up, 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 and back down. Not a great one. That's better. That's all you need to show. If you want to keep going, you can go for it. You don't ever need to draw the box if you hate it. I don't care. My feelings won't be hurt. What I don't want is sometimes if we don't draw it, you guys will draw something like this. Like if this was the box I was supposed to be drawing in, you'll draw like this and then call it a day. So make sure you know how far over it needs to go, how high up, and how far down it needs to go. So the reason I draw the box is I know I need to touch the box on all sides in order to know that I covered everything. All right, any questions on that? Let's do another one. Y equals -3 cosine 1/2 theta. So I haven't done a cosine yet. Let's do a cosine. Okay. What's my amplitude going to be? Let's call it just 3. Do you know what the negative is going to do? Flip it. We just drew a picture of it up here, didn't we? It just means I'm using this graph instead of the other one. It just flips it. I like amplitude to be a positive number because I think of it as a distance. So I don't want it to be negative. We're going to flip it. And then the period is going to be 2 pi divided by 1/2. This chapter is really big on fractions. So fractions are not your forte. We got to get that figured out. 2 pi divided by 1/2 is the same as 2 pi times 2, which is just 4 pi. Now, if you look at our picture, we are not labeled all the way out to 4 pi. If we were drawing this on our own, we can always change our scale. But for this one, I'm going to follow the scale that they give us. And I need to extend my graph out to get all the way to 4 pi. Seems about good. We'll call that 3 pi. We'll call that 4 pi. The other class is a little bent out of shape about like the other marks. You can put as many marks on here if you want. You can put the in-between mark for both of them. I don't care. If it helps you, good. If not, it's not that big of a deal to me. Okay. My amplitude is 3 and I go out to 4 pi. So I need to make sure that I've got my chart that goes that far out. Let's actually move this up a little bit. So I'm going to draw my little box because I like the box. 1, 2, 3. Got to go all the way out to 4 pi. 1, 2, 3 down. So I drew that orange box because I need to do a negative cosine in that entire box. So I really need to stretch it out. Instead of starting at 1, 0 like a normal cosine, I'm flipped. So I'd be down in the negatives. And I have to go all the way down to -3 because that's my amplitude. So I'm starting in that bottom corner of my little box. I'm also going to end in the bottom corner of my little box. And I'm going to finish this and then we'll spray desks. The middle point of my cosine graph is always the highest or the lowest point. So the middle between 0 and 4 pi is going to be 2 pi. So my highest point is at 2 pi. And then I know I hit zeros in between those points. So in between like the lowest and the highest, or in between the highest and the lowest, I hit 0. So the point in between 0 and 2 pi would be pi. That's where I'm going to hit 0. The point in between 2 pi and 4 pi is 3 pi. So I'm going to hit pi or 0 there. So now I'm going to stretch out my cosine graph. It's not perfect, but I've just got one cosine. A lot of people like to do this. So like, no, I want one cosine, not 7, one cosine in that little box. Okay. You are not being assigned homework yet. We are not ready to do it. If you want to start it, go for it. Your 4-3 was due today though, so make sure that I get that. And we do have not just a daily quiz, but plus a little extra on Friday. So make sure that you studied that. We went over all those questions. I will be in before school tomorrow at 8 a.m. if anyone wants help, or if you want to Zoom anytime, just let me work it out, okay? Yes. You guys are good to go. I'm just going to clean up. I don't think it's easily accessible. Give me 1 second. Let me stop the recording though, so people don't have to watch this on YouTube.